Hi, I'm Jody, and I'm an Agile coach. In this video series, we'll cover a number of Agile topics. But the topic for this video, the Fibonacci sequence. Fibonacci was an Italian mathematician from the 13th century. He created a sequence of steadily increasing numbers in which each number is the sum of the preceding two numbers. In fact, the golden ratio is derived from the Fibonacci sequence. You might be wondering why I'm telling you about a medieval mathematician. We'll get there, I promise. But first, let's set some context. When you look at the Agile methodology, one of the foundational elements is estimating story points. There's a couple reasons for that. The first is being able to build an accurate plan. But what it actually comes down to is that we want our teams to have the ability to determine how much work they can take on in any given sprint. So when we think of estimating in terms of the piece that controls our team's workload, that's critical. So we want to take a look at the techniques we use to estimate. There are a lot of different techniques, but the three most common: t-shirt sizing, time, and the modified Fibonacci scale. Since Agile's been around for a while, we have the benefit of taking a look at some case studies. These studies looked at what estimation technique provided the most accurate estimation over an extended amount of time. What the results found? Using actual time to estimate work turned out to be the least accurate. Now, t-shirt sizing is considered relative sizing. It performed better than actual time, but not as good as the modified Fibonacci scale. Let's see if we can prove out these results. Okay, I'm going to oversimplify this, but really quick. How big do you estimate that tree to be? But what if we asked, what tree's bigger? It's easy to see which tree's bigger, right? Even though that's a really easy example, I would bet if we took 100 people and asked them what tree is bigger, we would get 100% of the same result. But the answers to the estimation on how big the tree is would vary. And there would be questions about, what do you mean by big? Did you mean how tall it was or how wide it was? Those type of questions are what we call complexity when we estimate. Let's look into this relative concept. Imagine being handed two weights. One is 2.2 pounds and the other is 4.4 pounds. With one in each hand, but you're not able to see which is which, can you tell the difference between them? More than likely, yes, right? But what if you got handed a 44-pound weight and a 47-pound weight? That would be harder to tell which one was heavier. The first example is a 2-pound difference, but it's also a 100% weight difference. The second example is only a 3-pound weight difference, but it's also a 5% weight difference. That example is what psychologists refer to as Weber's law. It states, the difference we can identify between objects is given by a percentage. Now we can get that medieval mathematician back in here. Fibonacci got his sequence by adding the previous two numbers together to come up with the next number in the sequence, but it still follows Weber's law, with the exception of the first four numbers. Every number in that sequence after 3 increases by 60%. So in theory, what that states is if we have the ability to tell the difference in our task by 60%, we should be fairly accurate when we go to point it. In actuality, yes and no. We need to make some modifications. So what was modified in the Fibonacci sequence? The obvious one is we don't need the duplication of the 1. But when we start getting to numbers like 21 and above, that suggests a level of precision that just really isn't there when we go to estimate. Those are our larger tasks that need to be broken down. The larger numbers were replaced with 20, 40, and 100. This still allows us to identify our bigger stories that need to be broken down, but it also keeps us from debating if something should be a 34 or a 55. But with those changes, that gives us our modified Fibonacci sequence. Our next few videos will start looking at capacity and things like planning poker. Thank you.